Cool. Cool. All right, you guys should be able to hear me. Oh, it's finally Friday. We can finally relax, get on the stream. Turn this down. I got a copyright strike on my last stream because I played not so royalty-free music. So I'm gonna have to make sure that when I play music this time, it has to be royalty-free. I always forget that. So I'll play some music in a second, but kind of just sit down, chill out for a little bit while I pull up all the stuff we need. Cool. All right, it looks kind of laggy. Let me see if I can try to fix that. Sorry, y'all. Give me like 2 seconds. Okay, that hopefully made it better. I can't really tell, to be honest. So, all right, let's get on my computer. Actually, give me one more second. You know, I should have just kept the stream starting thing rolling until I was finished doing all of this bullshit, but you know, it is what it is. There you go. All right. Let's pull up. How do we do this again? Ooh, there you go. Seems like the glitch transition isn't working. Which I will have to fix later. OBS is now showing like this yellow box around this screen. It's kind of throwing me off. I know you guys can't see it, but it's supposed to let me know where I'm recording or something, but I'm going to drop the link to the repository in the chat for you guys because I want you guys to have access to this while I'm coding. And each time that I finish a certain section, I will push it up to the repository so that way you guys can have fun with it. Excuse me. There you go. Cool. Alright, I guess I actually should start getting started. Alright, first of all, music, right? Royalty-free music this time. Alright. What's my volume at? So I'm not like blasting. Cool. Alright. Can y'all hear it? Okay, that's good for now. If I need to turn it up, just let me know. Cool. Alright, so where did we leave off last time? So we can see into documents, code, Python, Codex. Clear, alright. And, oh yeah, we can actually just run the Python main.py now, because we actually fixed our shit. Alright, so yeah, it says Codex, and then, alright, so we have the actual overview thing. So we got Caesar Cipher done, and the base version of Visionaire done. What we're going to need to do in this video, or this stream, is do the Visionaire cipher, but instead of decrypting it with the key, we figure out the key using stuff. Should be a lot of fun. So hey, what's good, Matzi? All right. What am I doing again? All right, yeah, that's right. We're finding shit. So if I do, can I do Control B again? Yes, sir. There you go. So this is the unknown key video right here. All right, I'll mute the video obviously because we're going to avoid that copyright shit. But do I not have an ad blocker on? What? Hold up. Where's my ad blocker? We're not watching ads right now. We don't settle for less. Just chilling at work. Hey, what's up, Zach? Where the hell is my ad blocker? Yeah. Options. Whoops, that's not what I meant to do. I'm not paying for an ad blocker. Manage. It's on and you can run in private? Why aren't you doing your job? Why is this here? Mm-mm. Wow, we actually have to watch ads now? Imagine. Maybe I should just get YouTube Premium, you know? I should just take the giveaway. Speaking of which, we have a giveaway going on. YouTube Premium for 3 months. Click the previous video. I'll drop the link for it or something, maybe. You know, yeah, when I'm done with the stream, I'll drop a link for the giveaway in a comment. All right, so yeah, we got this blonde chick, and she's basically talking about decrypting the Visionaire cipher without the key, right? You're basically going to find, so you need to know the key length, right? And then you can figure it out using what's that thing called, weights, I think, or like percentages, or not weights or percentages. I'm tripping balls. Hold up. Control B, I think. Where did I search? Where did I save this? I think this is it right here. This right here. Yeah, right here. Frequencies, that's what they're called. Frequencies. Yeah, so we're basically... Is he even doing that? Key length guess? Ain't no way. David, you freaking Chad. That's the new pin comment. Yeah, that's the giveaway right there. Y'all should check that out. Did I actually pin it? Alright, cool. Yeah, I did. Thank you, David. Or Matzi. So it seems like this person went ahead and used Python and got the key length using frequencies. So I'm actually check this out. I'm actually gonna check this out. Alright, so let's copy this. Alright, so let's go into our resources and get poll. Is the music alright for you guys, by the way? Get poll. Oh my god. Get clone. This shit. Cool. Alright, I don't need Discord right now, I think. So I'm gonna just close this. Cool. And we should be good on the rest. So let's go on here. So if we go into our resources, yeah. So we have this visionaire.py. Because we already have ours that can encrypt and decrypt. But it seems like they were able to program out, able to program this out. By the way, I didn't really fully explain this, so I guess I should. You can basically find the key based on its length, and then from there, yo, you know what we should do? Should we do like, let's say you don't know the key length, but you know it's from like, I don't know, 5 to 25. Should we be able to like brute force a decryption? Yum, that might actually be sweet as hell, dude. Oh my gosh, I might do that. I'm gonna write that down. Yum, I need to finish the markdown files, cause like, hold up. So if you guys want to keep up with the project, by the way. Alright, hold up. I'm copying this, closing this. Hold up. Let me go deep dive in this real quick. There you go. So this is the repository for this project, right? There's something called roadmap right here. And this is literally the entire roadmap for the project, right? For example, Caesar Cipher, when we're working on Caesar Cipher, this is the entire roadmap and explanation on how we were going to get the Caesar Cipher working. The components we needed, extraneous information, literally the entire mathematical process of how the Caesar Cipher works with encryption and decryption based code for algorithms and stuff, like the whole thing. I wrote this down, by the way. This is all I wrote this, which is pretty sweet. So through that, we can also see like Visionaire Cipher. And again, I have like tables of exactly how all this stuff works. I never even like showed you guys this, I think. But definitely check it out. It's pretty sweet. What was I doing again? All right, Visionaire Server. We're working on Visionaire. So did I mention the ability? Yeah, the key decoding right here. This is going to be cool. So all what basic. I already explained this. I think. Yeah, I already explained how we're going to do this. I guess we should actually just try out the dude's code. I mean, like, can we? Can we cd into Visionaire Cipher Breaker, Python 3, whatever. Python 3 the Git file. No, Python 3, there you go. Text equals raw. Oh, no way it's in Python 2, bruh. Alright. Broken ass code. Let's guess we have to do this for ourselves. Hey, what's up, sister? That's right. I drink like all of my water within the first 30 minutes of stream. Actually, it's only been like 15 minutes. I can't even lie. Yeah, raw input. So what's going on with the raw input stuff? Is that like Python 2, right? I don't think raw input is a Python 3 thing because it's like tripping. And there's a bunch of yellow lines under it. All right, so time to find and replace all these raw input things with just input. Whoops. Select control, enter. There you go. Excuse me. Yes, sir. Enter E to encrypt or D to decrypt. Let's decrypt NJQQT. So MJQQT is the word hello encrypted with a key of 5. If we hit enter, do you know the key? So no, we don't know the key. Division by 0? Come on, bro. Alright. No way we have to fix this code. Come on. So it says main E to, if it's E, then we'll do this. So if we hit decrypt, we don't need to worry about anything but how they decrypt without the key. So if it's no, if torf, oh, true or false. Okay, I got you. So key length equals get key length from ciphertext. Oh, get key length. Oh, that's a function. Okay. Where is this function at? Just dude, you ever hear of doc streams, my man? I'm giving this person way too hard of a time. I'm sorry. I'm literally stealing their code. And cool. All right. How did they get key length ciphertext. IC table is a list. I don't like reading. All right. Splits the ciphertext into sequences based on the guessed key length from 0 until the maximum key length guess, which is 20. Oh, no way. My phone died? Dang. Alright, hold up. Technical difficulties, people. There you go. Alright, we're back. Cool. Alright. Oh, wait, what? Look at that giant chunk, dude. No wonder this thing isn't working. Def? Oh, there's no name for the function? Oh, no, I messed that up. Okay. I was gonna say. 0 division float by 0. What line is this, dude? Line 21? Line 21. Frequency sum 0.0. What did they find? N is equal to the length of ciphertext. With this stream, life will be going fast. That's what I'm saying. Mossy, you're going to forget you're even at work, dude. You're going to be so invested in this project. Oh, is it because I'm using Python instead of Python 3 because we fixed it? Why is a caps lock? Python 3, the vision. Oh, I put Python. Whoops. Python. I can't type. I really can't. Visionaire. Okay, so we're decrypting MJQQT. No, we don't know the key. Bruh. Alright, what are we doing? I need your opinion. Why is this not working? Like, why are they a float version of the length of the ciphertext? Okay, so it's running this function. Sorry, it's running this function. I'm dying at you robbing this man and being mad that he does that better stuff. I'm serious, dude. You can't put so like broken shit on GitHub. You know what I mean? For the record, I'm just kidding. I'm very thankful that this man put this on GitHub. He saved me probably like 4 hours worth of work. So I'm very grateful. Motzi. All right. Oh, Motzi. You know what this feels like? It feels like how we had to like fix Underguy's code in order to hack it. I feel like I had to fix this code in order to implement it. Mm-hmm. The app. I forgot there was a delay, but it's alright. The key is dog, 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 dog. Yeah, I know how it works. I just didn't want to program it. So for letter in the alphabet, frequency sum plus equals the ciphertext count of the letter multiplied by the letter minus 1. Okay. Using the index of the coincidence formula, IC is equal to the frequency sum divided by n multiplied by n minus 1. Okay. And then it returns the IC. So it can't divide by 0. So why is it 0? Because it shouldn't equal... Yeah, this shouldn't equal 0 if it is... Where's he getting that 0 from? It says you can't divide by 0. So n times n minus 1 is apparently 0. Yeah, 0 division error. How did he get 0? Float division by 0. Where's this 0 coming from, dude? Because that's the frequency sum, but they're appending. Oh, is this not working? It's like the plus equals not adding. Yeah, where's the 0 coming from? Because that's for the frequency, but they're adding new values to it, right? So it's just that count letter. Unless if this is just not working, and it keeps that 0 value. So is this not working? What does dot count do? I forgot. Python dot count method. I hate editing these videos, by the way, the streams, into the little xfruit.count cherry. Returns a number of times the value cherry appears in the... Oh, so we return 1. Yeah, I taught this. How did I forget that? Yo, look at the issues. I'm getting 0 division error for division by 0. There's a comment on this one. Alright, yeah, so that's what I did. I just switched it. When was this? February 23rd? Yeah, he got the exact same error I'm getting, dude. Alright, time to fix this thing. Or, you know what we could do? Find another file. Or, I could just program it myself. But we don't do that here. So, okay. Visioneer cipher. Unknown key, and then Python. Okay, I just realized I did the GitHub search for that, so I'm gonna just have to do that plain text. Visioneer, unknown key, Python. Let's try that again. Oh, boot Windows, that weird school regulation. Alright, cool. But for the record, they probably don't let you have Linux because they know you're gonna lead hacks them. Just do it yourself. I probably should, shouldn't I? Alright. We'll do it ourselves. After I look. Coursera, I don't like Coursera. They always be lacking. I just need like the math for it, and I'll just implement it. Alright, fine. We'll do it ourselves. And by doing it ourselves, I mean fixing this guy's code. Cool. So we will. Alright, we're gonna copy that Visioneer shit into unknown tag key.py. That's fine. SMH. Alright, cool. And cool. So we can close this. We don't need his bullshit code anymore. I'm kidding, for the record. Great project. Alright, yeah, let's get this unknown key thing going. So the maximum key guess is 20. So yeah, we're going to change this, right? We're going to make it so that people... Alright. So first thing we want to do is we want to be able to brute force the ability to decrypt the key. Y'all get that? Cool. So make it brute forceable. Is that right? Brute forceable. I should make that a note so I know what I'm looking for. Cool. Alright, and he has alphabet. So does he account for lowercase and upper? Because the key... Well, I guess it shouldn't matter too much. How did I do it? Yeah, I accounted for if it was uppercase or lowercase. Well, the key, it shouldn't matter too much, right? Yeah, we made the encryption key uppercase by default, even if they typed it in as lowercase. So that way we only had to count for one set of, like, ASCII characters. Or, I'm sorry, Unicode. Because Python, so... Alright. So... Array containing frequencies. So yeah, we have the frequencies. Yo, you imagine if we accounted for other languages too? Alright, so... We don't need to worry about their encryption okay, right? So we only need to account for the ability to decrypt without the key. We don't need to worry about how they're encrypting it or decrypting it with the key, right? We only need to see how they're doing it without the key. Because I know you use the, what's it called? The coincidence thingy-majig. Because, what's it called? The key is literally the same word over and over and over again until it reaches the length of the plain text or ciphertext. So if it's just the same thing repeating over again, you can use the law of coincidence or coincidence formula, whatever it's called, and use those frequencies to find the key that they're using in order to decrypt. That makes perfect sense. I get that. This dude was like, let's implement it into Python. So we're going to modify this so that way we only need to worry about the decryption process. So if it equals E, nope. We're not even going to ask them to do E or D. We're just going to tell them to fucking decrypt. Do I need like that ask variable? Did I delete an important variable somewhere? Else? We don't. There you go. Ask key equals true. All right, there you go. So now we're just going to shift this back over. Is that good? Awesome, perfect. So while ask equals false. What is with this code, dude? Actually, I think it's a really good piece of code. Bread, what's good, my man? I just realized how funny that probably sounded. All right. So now that we removed that, if we run the Python 3 visionary cipher.py, why is it asking to encrypt it, decrypt? We don't need this. No. All right, it runs the main code. We go to the main code. We're not asking them this anymore. We don't ask them. We don't have questions for them anymore. Ciphertext equals enter ciphertext to encrypt or decrypt. Okay. Is that what it asked us? Why is it asking us to encrypt or decrypt? E to encrypt, D to decrypt? Oh my gosh, I'm a dumbass. Oh, I'm so dumb. I'm so dumb. That's the wrong file. That's the wrong file. I'm running a different file. There you go. Yeah, see, enter. So MJQQT. So this again is hello with an encryption key of 5. If we run this, do you know the key? All right, we don't know the key. So why are we asking? Do you know the key? No, we don't. So if it equals no, we're going to do this. Otherwise, we don't give a shit, right? No, we're not even going to say if no. We're literally just going to run this process. We're stripping this code down to the bare bones. No, not even have an else either. It's just going to do its job. Cool. What functions do we not use anymore? Can I get rid of literally anything in here? I don't like how many comments it's throwing me off. I mean, you thought it's the wrong file? Yeah. I should have been paying more attention. Cool. So, let's try it again. Enter. All right. So MJQQT, right? All right, and now we just get our error that we've been dealing with. So what's wrong? Let's go through this code, right? We enter our text, which is MJQQT, and then, all right. So it gets our ciphertext. So let's print this. What is it doing right here when it's, because I'm not trying to figure what this fancy stuff is. I should whip out kite probably. Let's whip out kite. Alright, cool. I don't know where my camera is. Let me open OBS. Is that in like my camera? It's like, that's fine. It's like, can I like, there you go. That's good. There you go. Y'all can deal with that. Cool. So let's run this now. You know what? I don't even want to type in MJQQT anymore. We're commenting this out. Whoops. Is it just Control D or is it Control Shift D? Yo, how do you duplicate a line in is it Control Alt D? Control D? How do you duplicate a line? Ah, fine. All right. So we're changing this to MJQQT. Awesome. All right, let's run this. But we print it. All right, so what it does is nothing, apparently. Filters the text so it's only alphanumeric characters and lowercase. That's cool. Oh, so it takes away the lowercase. I mean, the uppercase. You know what's funny? I asked myself what this did, and there's literally a comment right here explaining what this is doing. That's on me. That's on me. Okay. I see the stream is like losing its shit right now. All right, cool. Oh yeah, welcome back, sister. All right, so I guess I should leave the. Well, we're minimizing kite for now. We don't need kite. So we have our MJQQT. It filters it. Okay. Then it asks the key. Wait. So get key length. Okay. So the first thing we do is get the key length of ciphertext. So let's go there. What is that doing? Get key. This does a lot of functions. Get key length. Okay, cool. And it gets our ciphertext. And then for I guess length in the range of the maximum key length guess, which is 20. So for I in the range of 20, it's IC sum. Split ciphertext into a sequence based on the guess key length from 0 until the max key length. Why does it start from 0? Because that would just be, okay, that's fine. Etc. Guessing a key length of 2 splits. Oh, okay. So was this working for him? Nothing, just watching Cosmo not read code. Okay, I'm sorry. I'm sorry. I should read the comments. I should read the comments. You guys are right. What's up, Adam? All right. So, example, guessing. Okay, yeah, I read that. This procedure of breaking ciphertext into sequences is sorted by the index. Yeah, I know that. The guessed key length with the highest IC is the most portable key length. Okay. So, obviously don't want to divide it by 0. Then why are we getting that error? Literally, I'm not even joking, dude. 0 division error. So apparently this is working. It gets the key length. So can we print out the key length? All right. So let me print the guess. Because the key... Oh, wait a second. Wait a second. I might be a dumbass. Hold up. Hold the phone. I was thinking Caesar cipher with that encryption. I could... Alright, Python 3 main.py. We're going to use the Visionaire cipher with the text of hello and a key of what is it called? I'll just say hi. Is that right? Am I missing anything? Yeah, I'm missing something. Oh, am I missing the tech key for encrypt? Yeah. So tech key to encrypt. Alright, osmotive. That's our text. Osmotive, right? Alright. Oh no, there's no S before that. So if we go back and CD into our resources and the Visionaire thing, and then we Python 3 our unknown key.py. Oh yeah, there's no input. So let's go into our main osmotive, right? And if we run this, that is royally pissing me off. Why does that not work? So the key is the word hi. Can we print out the keys? Where's the get key length? Alright, so we're going to print. Oh, is this the print statement throwing it off, maybe? Just in case? No? Okay, this doesn't work. So let's print. Alright, cool. So we'll just say first. Alright, so the first guess in here is going to be best guess. Yun, how the hell do you freaking duplicate lines? Does anyone know? Because I thought it was Control D. So Control Alt D, Control Shift D. Alright, well, I just have to type it manually. Print F. And then second. And then the second best guess. Yun, why didn't it print? Did it even get to there? Wait, so is it even making it to that point? Alt Shift down. Thank you, Adam. So we have our Vinny, right? Our ciphertext. Our key is the word hi. Let's use a 4-letter word. No, never mind. I'm too lazy. Osmotive encrypted with the word hi is this. We do all this fancy stuff. Then we okay. So they get the key length of ciphertext. Is this the first time they use the function in here? Yeah, so they use the get key length ciphertext. We go to get key length. Alright. Okay, and then they get index sequence. Oh, so they never get down here. So get index C has to be above. So they get the index C. And then it's error in here. Okay. So let's print n. Print n. So we'll just say n original. There you go. We already know what the frequency sum is. So then we can do a print statement here. All right, so we got the F string, and then we can call this frequency. Where's my autocomplete? I think I need to update visual. Frequency. I don't think I spelled that right. Sum, and then we can do the frequency sum. There you go. Yeah, why isn't kite doing its thing, dude? I think I need to update it, but I'm way too lazy to update it right now. I'll probably update it if we get to a good stopping point. Alright, cool. So what's going on here? So the n original is 5. And then it's 3. Then it's 2. Then it's 1. The frequency sum equals 0. Why? Why is it doing that? Alright, let me add a new line to the last one so that way I know when it's on a new iteration, right? So we can try this again. Cool. So we have our ciphertext. Then it says the length is 5, right? For frequency sum is 0. Wait, it's always 0. So it's 5 characters, so they're going to try it for all 5 characters. And they know that the frequency should be 2. Yes, because it's a 2-letter key. So it's right here. This is the law of coincidence right here. But why isn't it updating the frequency sum? Because it's supposed to change right here. This line is tripping some balls. Hold up. Note Actually, no, that's too far off to the side. I'll do it right here. Whoops. Note, this line is tripping balls. Alright. How do I fix that? So the frequency sum is adding on the value of the ciphertext.count letter. So is the count? Oh, is it dot count for? Oh, don't we have to split? Wait. So the ciphertext. We should get ciphertext. Get the length of ciphertext. I think the count only works on lists, right? Yeah, the camera is lagging. Yeah. It's cause I don't know. My internet's being tripping. My internet is tripping. Yo, why is the stream so laggy? What? I can't use this footage. What the shit? Alright, hold up. Alright, so I'm gonna close these for now. Maybe that might help a little bit. Oh, fucking. RSS version 5. My internet speed being tripping. Yeah. Again, this is why I don't stream. I can't mess up. I have to think about what I say. I have to be very cognitive. Alright, it looks like this stream's a little bit better. Yeah, I don't know why it's tripping. Alright, anything else I can close that I don't need? You know what? Fuck you, Kite. You're not even working anyway. Alright, that might be better. Alright? We're keeping these 5 windows only. That's it. It's crazy. I have 16. Alright, why is it tripping? Can you fix yourself? Alright, I'm going on my face real quick while I try to fix this. Because I don't want y'all looking at my shit. It might even look worse because of it only being on my face now. YouTube, fix your shit, please. It's not my internet. I'm wired in. I have the what's it called? I have Ethernet or whatever. Alright, let's see if this fixes it. Alright, it's like less laggy now. I think. Ethernet. Oh, okay. We're back online, apparently. What is the minifig banner in the background? You talking about these? That's Cthulhu. It's my favorite mythical creature. We got Elliot Alderson from Mr. Robot. Um, I feel bad that I forgot his name, but I think it's Huey. Hold up. Dude, I actually forgot his name. I feel so bad now. That guy is from The Boys, and then literally the rest of them are Deadpool figurines because I have this huge Deadpool thing. I feel bad. Damn, who was his name again? Okay, yeah, the stream looks like it's not tripping balls anymore, so we can get back to the code. All right, cool. Let's get back to work and only a little less choppy. What is the minifig in the background? Shout outs to Cthulhu for sure. All hail Cthulhu. For the record, I'm not part of the cult or anything. I just like the character. So we have Cipher. What was I doing here? Oh yeah. So I was converting the cipher text equal to cipher text dot split. Is that right? All right. And then it can do it. I think that's right. I hope that's right. Frequency sum. Oh, it just crashed. Yeah. All right. So we need, because I think count is only for. Oh, it works for strings too? I didn't know that. Yeah, so this is the line that's tripping balls. Why is this line not working? Ciphertext dot count. So wait, for letter in alphabet. Should we do a nested for loop? So should we say for each letter in the alphabet, and then for each letter in the ciphertext, if the letter is in the ciphertext, add it to the frequency sum. Okay, let's do that. So let's try this. So for letter in alphabet. Oh, wait. Wait. That could have been me being a dumbass again. I'm not sure. It might hypothetically just be. Because it's matching lowercase characters. No, it still doesn't work. Okay. We're back to this then. Alright, let's try this. So we do for each letter in the alphabet, and then we're going to do for each character in the ciphertext. We will check that if the letter is equal to the character, we will frequency sum plus equal to 1. Alright, that should hypothetically do the exact same thing. So let's comment this out. Okay, okay. Wait. So before we had frequency sum equal to 0. Now we have frequency sum have actual numbers. So that worked, but it still says float division by 0. So where are we getting the 0 from? So we fixed that part. Yon, this stream is tripping seriously hard, dude. I'm so sorry, guys. That's not on me. I'm blaming that on YouTube. Cool. Stream LED simulator. YouTube is locking? For real. Oh, LSD. Yon. So why are we getting the 0? Because now we have actual numeric values, right? So we get the IC frequency. Oh wait, line 32. We fixed it. Oh, so now we just have to fix them again, but in a different area. Look at us, y'all. Look at us making changes in the world. Okay, claps in the chat, boys. Hold up. So line 32 is the other area we need to fix. So this is the exact same formula that they did. Oh my god, I'm a dumbass. Never mind. Revoke those claps. Revoke. Drop F's in the chat now. Because now it just went down to the 30-second line. Yeah, okay, never mind. We didn't fix anything. Never mind. Why is that not working though? Like, I'm genuinely curious. F in the chat. Cosmos on the code come up. You know it. You know it. Alright, so y'all wouldn't drop claps, so y'all would drop the Fs. That's cool. That's cool. Oh man. Okay, so line 32 is where it's tripping. It does a frequency sum divided by this. So n doesn't change. So n has a value of 1. So 1 times 1 minus... Oh my gosh! I see what it's doing. You put the W in the chat? Thank you, sister. So yeah, so n has a value of 1, right? So then it just does 1 times 1 minus 1, which is 0. So 1 times 0 is 0, which is why it's failing. So what we need to do is, because now it was able to figure out that 2 is the value, right? It's like, that's the key. That's the key length. We were able to figure out the key length, which is 2. So from there, you don't see what it's doing. Do you know how the Visionaire cipher works? Let me explain this, actually. You guys are probably mad confused, and I'm just talking. All right, you guys are, sit down, buckle up. It's time for a quick lesson from Papa Cosmo. All right, we're going to go to our roadmap, and where's the Visionary cipher? Cool. So, Visionaire cipher, right? So, it's a polyalphabetic cipher invented by people. Basically, relies on the index of a character within the key. All right. So we have string keys in these Visionaire cipher typically. So each letter has an index. A has an index of 0, B has an index of 1, C has an index of 2, all the way to Z having an index of 25. All right. So let's say our key is literally the word key, right? So K has a value of 10 because K is 10, E has a value of 4 because E is 4, and Y has a value of 24, Y is 24, right? Cool. So now you can encrypt plain text by throwing the key at it, right? So, so we have, let's say the word encrypt is the plain text that we're going to encrypt. Then we have each of the indexes for those letters. So this is the word, again, that we're going to decrypt. So this is our plain text. These are the indexes for our plain text. Then we take our key, which is 10, 4, 24, and we just add it to those values. So 10 plus 4 is 14, 13 plus 4 is 17, 2 plus 24 is 0, all the way going down. And now we have these new indexes. So then we just take these indexes and match them to the ciphertext. So we have 14. So 14 is 0, or sorry, 14. 14 is the letter O. So that would be the letter O. 17 is the letter R, 0 is the letter A, and going down. And then to decrypt, you just reverse it, right? You have your ciphertext, get the index for each letter in the ciphertext, and then subtract each index of the key repetitively going down. And then you get the new indexes, and then you can encrypt it. Yeah, it's like a variating shift cipher, exactly. So we were able to get a working code to encrypt and decrypt it, but now all we have to do, or how to explain this? So now this is where we get into more complex topics, right? So this key, it repeats over and over again, right? So it's 10, 4, 24, 10, 4, 24, 10, and it will keep going down. So because of this and using the frequencies of the most common letters within the alphabet, a lot of the time we can figure out what letter or what the length of the key is through that based off of the coincidence of the letters being used. And then, so those are what the frequencies are. Like, where's this? So yeah, these frequencies are basically like how common each letter is. I believe there should be 26 in here. But. So basically, long story short, we can figure out the key that they use to encrypt the cipher and then use the key to decrypt it. Are we trying to detect the key of the cipher? Yeah, exactly. Yeah, so we figured out. So let me show you this, right? So if we go all the way back down here, this is our ciphertext, OMSTV. This is the encrypted word for hello using a key of hi. Hi has a length of 2, right? And if we check our code, it was able to figure out that the frequency is 2. They tried, because it's a 5-letter text, right? So they tried 5 letters, then they tried 3 letters, then they tried 2. 2 worked out the most, and then they tried 1. So these 3, now we know that the length of the key is 2, because if we check here, the key high has a length of 2. Now we can just kind of decrypt and brute force it from there. So that's the goal. If you want to learn more cool stuff like this, I actually have a Python course on my website. I hate to self-plug like this. I don't hate to self-plug like this. Let's go on my website real quick, boys, while the stream is just like shitting itself. Courses. Cool. Read more. See, I have a cryptography course right there. Oh, I need to sign in. I'm not signed in. That's fine. All right, cool. But if you're ever interested in learning the sheer basics of cryptography, there you go. Back to our regularly scheduled program. Did I clarify it already? You're already taking it? That's awesome, dude. That's awesome. Shameless plug? I have no shame. Everybody here knows Cosmodium's the GOAT. I need to do an updated version of it though, because I didn't teach Hashcat, which I should have. But other than that, I mean, it is basically the sheer basics. All right, so we were able to get the frequency of 2. This showed up the most, right? So now all we had to do is, I guess, implement that. But what it's doing is that once 2 shows up the most, and then it tries the 1, it needs to know that we need to use these 2. Excuse me, I'm sorry, guys. So, okay. So now that I explained it, I'm going to go use the restroom real quick, fill up my water. So I'll be right back. And literally give me like 2 minutes and I'll be right back. right, boysies. It kind of dawned on me. I was like, why get more water when you can have Sprite and some McDonald's? You know what I mean? I mean, it kind of dawned on me, you know? I'm switching my earphones to this side so I can look better on the camera. Cool. Dang, the stream is still like mad laggy. I'm so sorry, guys. I don't know why it's like that. Alright, what did I miss? Already taking it. The cryptography. I try to solve arguments on the daily. Yeah, that's cool. This script is like 2 years old. Try Python 3. Yeah, I converted it to try Python 2. Nah, I would, but they're kind of like what they call removing Python 2, or like stopping support for Python 2 or something like that. So I'm gonna try to keep it at Python 3. Plus, I don't know all the Python 2 syntax. Sounds like a good idea, but you don't. Plus, if I did Python 2, because I already have, so this unknown key, you guys can't even see my screen. Hold up. All right. So this unknown key.py is basically a proof of concept that we're going to implement into our Visionaire Caesar.py, right? Because we already have a working version of the code. So if I can cd out of here, Python 3 main.py. This is the Caesar site. This is the Codex project, right? So it's a shell script for cryptography. So I can do like tag V for Visionaire, tag E to encrypt, tag T for the text hello, and then we can do a tag K for a key of hi, and then we'll get that OMSTV using the Visionaire cipher, right? And I can do the same thing, but for like the Caesar cipher. So tag C for the Caesar cipher, and then we can do key of 5 for hello, and then we'll get Caesar cipher, and then this encrypted stuff. So we have like the script. Those are the only two ciphers I implemented into this so far, but they're all using Python 3. I don't want to go back through and change it to Python 2. Bread sounds like a good idea. Oh, it's not as laggy? Alright, perfect. Is my phone still dead? Oh my god, I need to plug this in. Cool. If I need to explain anything, just let me know. You guys can probably hear me like digging into this McDonald's bag. Cool. So, unknown key. Damn, why is my phone blowing up? Ain't no way my phone's at 44%. It died. I plugged it in and it's at 44%. Sorry, y'all. People are texting me. Give me like 2 seconds. Alright, perfect. Alright, what are we doing now? Cool. Um, so we got the frequencies working. However, all right, let's account for the frequencies, right? So we'll say, all right, what's it do? Let's see what it's doing after this so we can account for this. Dying at 40% sounds like an Apple device. How did you know? No, it died because it was at like 10%, but I plugged it in and it booted up at 40%. Most definitely an Apple thing, yeah. I love streaming, by the way, guys. Streaming is so much fun because you guys are here. Watching me just struggle to steal people's code. I mean, I got a whole burger too. Should I turn off my camera because I'm like eating food? I'll eat this after I stream. How far are we in? How far in are we? We're about an hour 27. I usually stream for about 2 hours, 2.5 hours. All right, let's keep going. So, we were able to find the formulas, right? We found, I have to scroll up now. All right. So we know that the length of the key is 2. Look at that. We were able to figure out 2.0, 2.0, 2.0, 2.0, 2.0, 2.0. We need to account okay. How do we make sure the code continues to know? What happens when this is done? It returns IC, right? So it returns IC, which is about, so the frequency sum divided by, oh wait, is the code not working still? All right, let's cd into resources, Visionaire, Python 3, the unknown key. Oh, so it works with all of these. Oh. So it's looping over this function. Yeah. So for this range, for the range, okay. What's the guess length? For guess length and range? Oh, I'm a dumbass. Never mind. I forgot how a for loop works. So we'll do for 0 in the range of 20. So, oh, so we'll skip over the 0. Got you. So we'll do 1. So it does this perfectly fine until, so what is this returning? You know what would be really cool if we did? Implementing like a brute forcing of the Visionary cipher using a list of possible keys. Wouldn't that be cool? as well as this. That is such a cool idea. I'm writing that down because I'm going to forget that. All right, where's the roadmap? So right now we're implementing. I'll just do unknown key, and then implement key wordless. Root. That's a cool idea, dude. All right, so now that I know what's wrong, hopefully we can get a basic idea of how to fix it. What's really going on, to be honest and be quite frank, is where's the freaking thing? It's like line, yeah. So it's working, and then it gets to 1, and then it So should we just? Oh, we should find a way to save like the previous. Okay. So we'll call this previous frequency maybe, or previous sum is equal to I don't know, 0.0. And then so all we're going to do here is set all right, so we're going to try this. So try and then accept, was it divide or 0 division error or something like that? 0 division error. When you omit it, it still return trash keys. Or are you talking about the ISIS Jam? I'll see you, man. So when you omit it, it will still return some trash keys. Are you talking about like having a word list of keys to brute force with, and then checking to see if they're legit? I mean, are you heading out? All right, cool. All right. So accept 0 division. Oh, you mean this code? Yeah. So right now, it's actually sending this trash key in trash key. We already know that this is the most likely possibility. So this is probably the one that it's gonna automatically use. So I'm probably not gonna have it omit these. Yeah, I got you. Good night, dude. This implementation might be wrong. Yeah, it actually is. I'm trying to fix it because, yeah, I'm basically just trying to fix it. Because we have these. Because we know we're getting these, right? And the length of the key is 2, and out of these, it should be able to tell. Okay, the key length is 2, based on this data. So now we should be able to move to the next stage by being able to remember the most populated key. What I'm trying to figure out is how can we have it remember which key was like the most the most used. How can we make it remember that the number 2 is the length of the key? There's some C++ implementation. Why don't you compare or port them to Python? Is there? I haven't. If you know some C++ implementation for this process, because this isn't decrypting the Visionaire cipher. We already got that with Python, because we can encrypt it and decrypt it perfectly fine. The problem is discovering an unknown key based on letter frequencies. So it gets to here. Oh, okay, I see. So it's doing it for the length of the... Okay. So how can we get it to stop? Wait, so no matter what, if n is equal to 1, this formula will not work. So we can just check to see if it's 1. Then if it's 1, it will have to return the previous value, right? Let's print IC, because that's what's being returned. Oh yeah, I have the new line here. All right, so we'll get rid of this new line here, and then we will just concatenate a new line right here and run it. There you go. Oh my gosh, freaking stuff. I see. All right, you good now, Python? Cool. So it's 0.25, 0.5, and then 100%. Yeah, exactly. So if it is 1, it should stop, right? All right, let's do an experiment. Let's do an experiment. So if we do this again on a different cipher, and it still gives us the same thing, we know it's wrong. All right, so we're going to do this. Shut down. Cool. So let's do a different Visionaire cipher. Cool. All right. So CD out of here, out of here. Yeah, that makes sense. All right, we'll do that. So CD out of here, out of here. And then we'll do a Python 3, the main.py. And we're going to do attack V for Visionaire, attack E to encrypt, attack T for hell. Let's do a different word. We'll do Cosmo. And then attack, I don't know, K for OH. So it's a 2-letter key, and it's using GV. Actually, no, let's do a different, let's do 3 letters. OHT. There you go. So let's try this. And the key should be a length of 3. So let's cd back into our resources, Visionaire, and then Python 3, our unknown key, Ep.5. And if we do this, okay. So it still thinks the key length is 2. Interesting. Oh, so that's why it has that second guess, doesn't it? Yeah, it has a second best guess. So that's why we're going to incorporate that brute forcing method as well. Incorporate the brute forcing of this as well as a keyword list. Does that make sense? Oh my gosh. Cool. So what's next? Wait. All right. So let's cd back out of here. Might need a longer sample. Yeah, that's what I was thinking too. So let's actually do that. Python 3, our main.py, and then we'll do attack B for Visionaire, attack TE to encrypt it, and then we're going to do our text of Cosmodium. Cool. And then we'll do attack K of, I know my camera's covering the last part, but it's fine. All right, should we use a longer key? We'll use a 4-letter key. We'll use ASDF. There you go. Cool. So this is awesome. So let's go down here. So our key length is now 4, right? Cool. So let's cd back into resources, back into Visionaire, and do a Python 3 unknown key. Okay. So our key length is 4, and it says there's a 0.3% chance, right? There's a 0.5. It likes that number too. And number 3 shows up quite a few times too. Yeah, so there's no way it's going to be the number 9. So what we really need to figure out, first of all, it may need a longer sample, it may need to get rid of something. Sure. Yeah, if it breaks ciphertext into 20 sequences, we need text longer than 20 characters. No, the 20 is representing the maximum key length. So it's a key no longer than 20 characters. Our key is 4 characters. We're no longer using high as a key. We're now using ASDF. And our plain text is Cosmodium, right? Cool. So with this information, so it says 0.3. Because its first guess is 2, and its second guess is 3. Am I wrong in guessing that? Sometimes I wish it just worked, you know? Oh, but I see what you're saying, though. Because the key is 20 characters. We could make I guess. Well, no. Plus, if the key is longer than the actual ciphertext, that could throw some problems. This is annoying. Alright, let me think. Because all the 20 really is serving is like the loopability of it. Because it's checking for keys within that range of 20. But it'll only stop at the length of the cipher. Yeah, so for whatever in the maximum... So this is 20. This is the 20 that we're talking about. Then it does for each I in the range of that guess, and then for in the length of that ciphertext in intervals of the guess, because it's accounting for the key length. Then it does ciphertext I plus j. So the IC sum is equal to the sequence. So sequence is an empty string. Okay, but we add it. Let's print sequence out here too. Because that's what we're throwing into here. I don't know where that lag spike came from. I didn't like that. Alright, so we can easily identify it. We'll just do sec and then our sequence. Awesome. Alright, let's try this. So sequence R, RM, V, V, Z, G, G, L. Okay, so this is our string, or our plain text, C, G, V, R, O, L, whatever. So the C, C, G, C, G, V, all the way down. And, okay, so... Okay, 9, 25. Damn, that's hard. It's 2 a.m. or it's 12 a.m. Here, but when I get out, take the sequence, let me just try to port it into Python. That's cool, man. Appreciate that. And this the whole thing is on GitHub, so y'all can check it out, fork it, like it, contribute, whatever. So so wait, GRVZ. GRV. or GVR. What's this doing? CV. Oh, so it's skipping each letter. Checking. Oh, okay. So it's skipping at 4, 3. Okay. Okay, but why is it not accounting? I want to see what would happen if we can fix the divide by 0. If we can just account to see if its length is equal to 1. Wait. So what's the sequence if it's doing 1? So if the sequence has a length of 1, so if sequence, or if the length of sequence is greater than, dude, my computer is like freezing up. What the hell? No, it's just that I need to update VS Code. I have not updated it in so long. I know that looked mad laggy too. I'm so sorry, y'all. Alright, so if the length is greater than 1, we'll add it. Alright, yeah. And then we'll print sequence. Wait, let me make sure I'm doing this right. Okay, yeah. Cool. So these two need to be tabbed over. Alright, and then well, we shouldn't run this. Wait. Where is vision intersect with the pi? Yeah, so I see some goes out of it. So we shouldn't run the sequence. As long as we don't add the value to sequence, it should work. Okay. That looks good. Let's try this. Nope. I told it to stop if it got to the length of 1. The sequence has 1. Oh my gosh. Why? Oh my gosh. I hate math. I swear that's all cryptography is at this point. It's just math. All right. How on earth are we going to fix this? Where are we exactly? Where's the code we're trying to fix? It's like up here. Yeah, all right, so we've got that working. So that's good. It seems like. That may have not done anything to change it, to be honest, but... So if we look at the output of the code, we see that if there's only one sequence with one letter, it will fail. It won't divide. Oh, maybe if frequency sum equals 1.0, then don't do it. Well, we should stop it before we even run it. So where are we running it? Like right here. So if their sequence is greater than 1, it will do this. Because we have R, RM, and then we have O. So this doesn't work. So can we do like a... Oh my gosh, Sean. All right, what are we doing again? All right, let's get rid of this. Cool. Now we're going to go up here. We need to stop it if it has a length or if it is a value of 1, right? So then we can take our previous sum and assign it the value that we're returning. All right, instead of previous sum, previous IC. All right, and then instead of returning IC, so we'll say if IC is greater than 1, we will return the IC. Else, and then we will return previous IC, and then all we'll have to do is set our previous IC equal to IC. All right, perfect. So then in here, we can do previous IC, and then at our get index C, we can do sequence and previous IC. Does that work? Still didn't work. Oh, greater than or equal to 1, maybe. Nope. So greater than 1, else. Oh, wait. Let's take this out. There you go. and then okay. So if we do this, okay, let's try this. Unbound local air variable. Okay, so we fixed that problem, I think. Oh no, did we? Zero division error. Oh, we got two errors now. Oh no, yeah, alright, it got worse. Alright, this stream's lagging way too hard. Alright, so this is what I'm gonna do. Alright, the stream is lagging like crazy, and we're not getting this code working. So I'm gonna end the stream here, and then I will get back to this later. I might work on some of it off camera because literally it's just a shit ton of debugging. But again, I appreciate it, guys. Hope you guys enjoyed the stream from what you were able to watch. Hopefully it wasn't too much of a lag. And yeah, so I'll see you guys later. So make sure to leave a like, subscribe, and do that usual stuff. But I'll see you guys later. So stay happy, stay positive, and as always, happy hacking.